Hello everyone, welcome to our first podcast. Here I am Saurabh Kumar. Uh, Let me introduce a bit more about myself. So I did my graduation in computer science from Army Institute of Technology, Pune. After that, I did internship at Pubmatic, and then I did work as a software developer for 2 years at Dhruva. After that, I decided to come to Boston, Northeastern University, for my master's. Here I am with Sneha. She will introduce.
Yeah.
Yeah.
Thank you, Saurabh. So, I did my engineering in computer science from Cummins College of Engineering in Pune. After that, I worked as a software developer for 2 years at Oracle. Then, it was decided that I wanted to do masters from the very beginning.
Right.
So yeah, I did work for 2 years at Oracle, and then I started applying for colleges in US, and finally I landed in Boston, and I'm in the same university as Saurabh. At Northeastern University studying IS, and I'm currently working as an intern at Gene as a software developer. Majorly, I'm working on Python and Django framework. So yeah, that's about me.
Okay. So thanks for listening our introduction. Now we'll move to the important thing. So why are we here? So we are here like we'll be hosting or and posting all the tech related things. So our first topic is system design for today, and let's see. So Sneha, please tell us a bit about system design. What is system design in exact? Like, please.
Yeah, so that's a very interesting topic actually. Like, system design is asked in all major interviews and almost in all the FANG interviews. So, very interesting topic. And so, talking about system design, what exactly is it? So, like, just introducing it to someone who is just doesn't have any idea about it, I'll say, like, let's just take one example. Like, you're planning a birthday party, okay?
Right.
And you have so many things to plan for it, like to make it more exciting, make it more fun. So, like, for example, you need to plan. First thing is like, where do I plan my birthday party? The
Right.
second thing will be, how many people do I invite? What games can I plan? What food should I plan? So all this planning is basically uh, what makes your birthday party fun and exciting. So similarly, like if you're designing an application, talking in technical terms, you're designing an application or some kind of product, you need to plan, and you
Right.
need to uh, make sure, like, whatever requirements, what are the requirements, what exactly, how scalable do you want the system to be, how reliable it should be, what should how, like what makes it more maintainable, what kind of database do you need to use for your applications, and
Right.
so many things. Like, it is like a list of full of things that you need to design a system.
Right.
So that is what exactly system design is, like all the things that are required, like a larger picture from outside
Mm-hmm.
of how the system should look like.
Okay, get it.
So I think Saurabh can also explain a few more points on
So,
this.
for what I feel is system design is the basic thing, very first thing that anyone should look. So, whenever after learning programming language, right, for software developers, I'm talking about. So, after learning, when you know how to write some basic code and everything, and now you are ready to design some application and right. So, first we should always know what is the actual requirement, and we should understand those requirements, and on top of that we can make our application, right?
Yeah.
So understanding our requirement in a complete way and making that application, exact that application for to complete that requirement, is what system design will do. So how many customers that application wants, how many active customer will access your application, these all things. So we'll talk about that with an example.
Yeah.
So what do you think, Sneha? Which topic should we pick for today? Like, any idea?
I
Like,
think,
for the start, right, we
yeah,
can take some easy topic, and then by going forward we can like move towards the some
yeah.
more complex topics. But now we'll just start with some basic topic. What do you think?
Yeah, I think you should start with the basic one.
Okay, so I think okay, I have one idea. So one of the basic topic that like I did study before, right? So it was like URL shortening, right?
Oh, very interesting one.
So it's a basic topic. It will really help everyone here. So let's choose that topic. So what do you think, Sneha? How will they will be designing that URL shortening system for us?
So I feel whenever we are designing
Mm-hmm.
a system, we are doing starting with system design. I think the most important thing here is to ask the requirements.
Okay, get it.
So if you are taking my interview, I would just ask you all whole lot of questions on how my what will be the requirements here.
Okay.
So okay, so like what exactly do you mean by URL shortener?
Okay, so what I mean is, for example, I have a very long, or maybe it does not make. I have any short. I have any URL. Okay, it does not matter. It's long or short, right? If I want my service to accept that URL on behalf of that user and convert that URL as a small URL, maybe of 4 to whatever length we want. We can decide on that later, and what are the reasons of deciding that length, that also we'll discuss. But yes, we just want a big URL to convert to smaller URL, and every user should access it.
Right.
Yeah, so that
So
is the basic requirement of
yeah, so you
that.
mean like some bitly kind of thing?
Yeah.
So user gives you a link,
Right.
that link should get converted into a shorter link, and then if we click on that link, it should redirect to the original link,
Yes,
right?
agree.
Okay. So what is the scale here that we are talking about?
So since we are starting out, let's think of our starting users can be like 1 lakh user. If our app is starting with 1 lakh users, what if we want to store around maybe 1.1 million to 1.5 million of shortened URL. So that's what scale I'm talking about.
Okay.
So please do tell us what is the importance of scale here, and why we are considering the number here. What is the benefit of number here? When I say the scale should be 10,000, and when I say the scale should be 1 million, what is the exact difference here, and how it will impact on my system?
So yeah, whenever we are talking about scale, it actually impacts our system in a very large way. Like, so if you're talking about databases,
Right.
so how huge and how many databases should we have in our system? Or maybe how many servers are we using here? So
Okay.
that plays a very major role on depending on how many users are gonna use our application.
Right.
So if there are gonna be a lot of users, you need a lot of machines, a lot of servers, so that and a lot of scalability, so that whenever any kind of traffic is coming in your way, that gets redirected, and your user don't have to wait for the response.
Okay.
So that's why I think scalability is important, and how many users are going to use your system is very important here.
Okay. Okay, so let's start our system design for this. Okay, so what is the next steps now?
So I just wanted to ask, like, how many, like, is there any kind of restrictions on what characters we can use, or what symbols we can use here?
Okay, so for now, like to ease up our process, so what I think is lowercase a to z and 0 to 9, I think we should be fine with that much of characters. So let's go ahead with that.
Okay, yeah. Do we also want our application to be used somewhere geologically in some different countries?
For now, let it be in our same place, but yes, we can also discuss why does that thing matter, and how, if that requirement comes,
Right.
how can we get to that point.
Okay. Okay, so as we mentioned, as you mentioned earlier, that we have an initial requirement of 1 to 2 million links to be stored in our system.
Right.
But what if we are using this system for a longer term, like
Right.
say 10 years,
Yes.
and we're storing a lot of unique links in our system? So we'll require a much bigger view here. So I was thinking about something like base 62.
Okay, I agree with you. So, for example, if we are storing around about, let's say, 2.5 to 3 millions of records or links, maybe in the span of 10 years.
Yeah.
We are thinking for 10 years right now. So, yeah, you're right. So, we'll be considering a system like base 62 system where.
Correct.
So how the base 62 system is like, it represents a number. So, for example, 0 to 9, small a to z, big A to Z. So that's how the number system, actually, that base 62 number system works, right? I agree with you. So can you just explain a bit on the components of the, like, how should be the actual design of URL shortener?
Yeah, so let's break this into components.
Right.
Basically, we'll have a web interface wherein the user just enters their long URLs
Okay.
and receives their shortened URLs.
Agree.
So the next thing is load balancers.
Yes.
So what if we have multiple requests coming into our server?
Yes.
So you need many servers here, and the load between the servers should be divided. So what happens is, if you don't have load balancers, it is possible that whatever request the user is giving, it may take a lot of time for them to get it back.
Yes, our service might take a lot of time
Yeah.
to process each request. Like, a better approach will be like to
Adding load
have a
balancers.
load balancer to
Yeah.
our system. Right?
Correct. We also need the web servers.
Right.
So basically, what web servers are for will be like for shortening the URLs and for storing the mapping between the short URL and the long URL, and also to handle the user requests.
Okay.
So the next part will be adding databases to our system. So what will be the database used for? Like, these will be used to store our mapping between the short URL and long URL.
Right.
So here's where, like, basically scalability is important.
Right.
We'll need distributed NoSQL databases to handle massive amounts of data efficiently.
Right. I agree on that point. Right. So since our requirement is like a lot, we need to store a large amount of that links. Right. So yeah, NoSQL will be an appropriate database for our system. Yes, I agree with you.
Yeah, and also, like, we also need a redirection service.
Right.
So basically what it will do is, it will access the short URL and it will redirect your short URL to the long URL.
Right. Yes.
Correct.
Okay. So on top of that, right, I will also suggest, right, we can also have some kind of memcache service, right, where we can store the frequent accessed links, right, so that so we can reduce the time of request response time.
Correct.
Right?
And I feel that what cache you suggested, cache database, memcache, it's very simple and very reliable.
Right.
I think Redis cache is really good, but the problem with it is, we don't need that much of functionality here in our system. It's very the Redis. Sorry for cutting you.
No,
the Redis system is Redis cache database is really reliable. It adds more functionality, but also it's not required here. So memcache would be a better option for us.
Right. Okay, so let's go ahead with our approach. So, like, okay, so how an actual in our system, right? In our backend system, how in actual we'll be performing that URL shortening? What is the what do you think? What should be the actual way of shortening that URL? And how we will be storing that URL into that our database,
So I think there are multiple approaches to do this.
right?
So I will go step by step,
Okay.
and I'll approach. This is not the efficient solution, but this is obviously like this is the one of the solution, but not the most appropriate one.
Okay.
So what we can do here is we have a long URL.
Okay.
You generate a random number for that specific URL.
Okay. So you mean that every long URL, every URL that we receive from the user will always be represent in our system, will always be represented in the form of number.
Correct.
Right?
Yes.
Yes, I agree with that.
Yeah. So a random number is generated for that link, and B62 algorithm is applied
Okay.
on that random number.
Right.
That B62 algorithm, when it is applied on that random number, it gives you a seven digit unique code.
Okay.
So we have decided on the length of the characters we want for our short URL, that is 7. So a 7-digit unique code is generated for us.
Okay. So why 7? Why not 2? Why not 3? Why not 10? Why 7? Why? What is the reason of choosing the length of shorten URL as 7?
Yes. So if you see the number of combinations we get after using 7-digit unique code is basically if you're applying B62 algorithm,
Right.
so that is having 62 unique like 0 to 9, that is 10, then A to Z, that is 26,
Right.
and small a to z, again it is 26. So
Right.
in total it is like 62 unique code, unique characters. So if that raised to like 7
Right.
7-digit unique code
Yes.
gives you around 3 trillion combinations. More than that, I think it's more. I don't know the exact number, but it will be in trillions, right?
Okay.
So that's a number that will give you like more amount of unique number of combinations.
Okay. Get your point. So
Yeah.
like to fulfill our basically 10 years of requirement, we'll be considering 7 as the length, as
Yeah.
it is the more appropriate one for our system, since it gives like 62 power 7 is
Around
up-
3.5
yes,
trillion.
around 3.5 trillions.
Yeah.
Right. Yeah. We'll go with that. So yeah.
So what happens now is like after you apply B62 algorithm on your random number, it generates a 7-digit unique code for your
Okay.
long URL,
Right.
and that 7-digit unique code is linked with your long URL.
Right.
So this takes place for every URL that comes, long URL that comes. So every URL that comes, it will number will be generated for it. B62 algorithm will be applied, and you get a 7-digit unique code for
Right.
each of the long URL.
Right.
So yeah, so this is how you can convert basically a long URL to a short URL by using this B62 algorithm here.
Okay. Yeah. So one of the issue which I'm seeing in this solution is, what if that random generator generates the same random number for 2 different long URLs? So what could be the possible solution for that?
Yeah. So yeah, this is the major issue with this specific algorithm, like this specific technique. That what if like the same number is generated for
Right.
two different URLs, right?
Right.
So there comes in our second technique, which is
Okay.
more better, which is using MD5 algorithm.
Okay.
So what happens here is same thing. You have a long URL, random number is generated for that. Then MD5 algorithm is applied on it, and you get a 25-digit long unique code.
Okay. MD5 is, it's a hashing algorithm,
Yeah,
right?
correct.
So what does it take
So
as an input?
It takes your it's same. It's very similar. It takes a random number and generates a 25-digit long code.
Okay, then what we'll do?
and we just pick out 7 from that 25.
7 characters on, but it's I think there might be possibility that starting of whichever 7 characters you are selecting, right?
Mm-hmm.
That can also be some like same for some URLs.
Yeah, that's possible, right? Exactly. So I just told you, right, that we have multiple options to do this, multiple techniques to do this, but efficient one is yet to come.
Okay.
So these, I mean, yeah, obviously this is better obviously than the first technique, because the chances of getting the same unique code for 2 URLs is very less compared to the first technique.
Okay.
So
Got your point.
here we have the third technique.
Okay.
So instead of doing uh, using the B62 algorithm or MD5 algorithm, what we do is we apply a counter. Instead of taking a random number and applying B62 on it, we take a counter and apply B62 on it
Okay.
for every long URL. So there is a long URL,
Okay.
then you have a counter. So say starting with 1 for
Yes.
first link which comes, then 1 with on 1 we'll apply B62.
Right.
For 2 we'll apply, second link comes, we'll apply for 2
Right,
we apply
right,
B62.
right. And for that lot of servers we are getting, we can define a range of numbers.
Yeah, but that comes later. So what happens now is, if a counter is applied,
Right.
right?
Uh-huh.
What if that one counter is not working? The whole system goes down.
What is
So
not
now we are applying. We have a counter, right?
working? Right.
And we are using that counter to get a unique code, 7-digit unique code. But what if that counter is not working?
Okay, so got your point. So if the whole system goes down, then that might become an issue for us. So what is the possible solution for that?
One way is that we can add multiple counters.
Okay.
Do you find any thing bad about this?
Yeah, we can have multiple counters, but I didn't understand what is the correct name for this? Like
No.
how this will work?
So what happens if you add multiple counters here is, it can reach its maximum limit, right?
Right.
So there's the maximum limit it reaches, and then what?
Right.
So the more appropriate thing here to use is Zookeeper.
Okay.
So what this does is, for every link for some links we can assign a server to it.
Right.
So for example, 1 lakh to 3 lakh counter, we assign it to server 1.
Okay.
Similarly, if
3 to 6.
3 to 6, we can assign it to server 2.
And same.
And if, like, for example, if one of the
Ranges.
counter goes down, we can apply some other counter to it. Like,
Right. If one of the
which was not
range
used.
is finished, if suppose 1 to 3 lakh is finished, we can our Zookeeper can create another range.
Yeah.
And we can always have some range for us. Yeah, I agree with
Correct.
you. Yeah, that feels like a correct approach.
Yeah.
to,
So
go
I
ahead.
think this is approach which is more efficient and better than the rest of the ones which we explained.
Yeah.
But yeah, but those are good approaches as well. But like obviously all the
It all
approaches-
depends on the
scalability
which we are
yeah.
working on, right?
Yeah, exactly.
Okay. So I think it's a good discussion. It's a good session. Thank you so much, Sneha, for like coming out and explaining
My
so much to
pleasure.
our guest and me as well. And yes, we all are student here, so we might have done some mistakes. So feel free to correct us. Feel
Yeah.
free to guide us. What do you think of these approaches, and can you guys come up with some unique and different approaches?
Also,
Feel-
let us know if you have any
other ideas.
yeah, ideas
just to,
on
like-
how we can solve this.
Yeah. Okay, guys. Thank you so much. Bye bye.